Good afternoon, everyone. We have our lesson this time that is in the study of variation. So, measures of variations. So, what are the measures of variation? One is the range. What is the range all about? This is about the highest score or highest observed data minus the lowest score or the lowest observation of the given data. Let us try to consider this set of examples. Let us say you're giving a test and the score that were obtained by your students are the following. So you have 45 having a sample of 5, then you have 48, then you have 20, then you have 50. So 1, 2, 3, 4. So we still have it's 50. Then let us have 30. Now, what is the highest score presented in the given sample? So let us review 45, 48, 20, 50, 30. So our highest score is 50, while the lowest score is 20. So you can see there 45, 48, 20, 50, 30. So what is the difference? So that is the difference is 5 minus 2 is 3. So it's 30. So this is our range of the given data. What are we trying to estimate here? We estimate how far the lowest score from the highest score. So the difference is 30, and the question here is, would you be happy if this is the difference? If the difference is very small, would you be happy if it is small? Or if it is big, if the difference is big, would you be happy still? So you are going to consider that when there is a big difference, that means to say there is a problem on the lowest scorer. So you have to go back to the lowest scorer, the story behind the student, why she or he obtained the lowest score. So the second one is the measure of variation is the MAD. No? So measure of variation, that is mean, absolute, deviation. Okay, so we call it the MAD. The MAD is equal to the summation of the absolute difference between the observed data minus the mean of the given set of data divided by n. Let us try to consider the following score of students in a given exam. So there are 3, 5, then 2, then 8, and 7. So what are we going to do first with this data? We're going to get the mean because it's needed. So 3 plus 5 plus 2 plus 8 plus 7 divided by, okay, so 1, 2, 3, 4, 5 divided by 5. So what is the sum now? That is 25, no? 25. 3 plus 5, 8 plus 2, 10, 10 plus 8, 18 plus 7, 25. Divided by 5, that our mean is 5. Now we are ready to move to the next step. So we know that our mean is equal to 5 from the given data. So let us try to erase this given solution so we can proceed to the next. And then here, let us try to make our x sub I column here. Let us have 3, then 5, then 2, then 8, and 7. And then our mean is 5. 5, 5, 5, 5. So, let's try to get the difference now. So, 3 minus 5 is negative 2. So, let us try to make the absolute value immediately so we will not have the wasting of time. So, 5 minus 5 is 0. Then, 2 minus 5 is negative 3. That is 3 because it's absolute. Then, 8 minus 5, it's 3. And then, the last one is 7 minus 5 is 2. So, get the sum of the difference. So, we have 2 plus 3 is 5. 3 plus 2 is 5, so you have 10. So, applying it to the formula, the sum is 10. That is divided by 5. So, our mean absolute deviation is 2. That is how to obtain the mean absolute deviation in the measures of variation or measures of variability. So, let us try to proceed to the next part, which is the study of the variance. The variance here, this is widely used in the study of making estimations, and where the variance has two things to consider when you compute the population variance. So in symbol, that is omega square, that is equal to the summation of the quantity of x sub I minus mu, that is the population mean, squared all over n. No? So that's a formula. But for the sample variance, that is S square, that is the summation of x sub I minus bar x, the mean of the sample quantity squared all over n minus 1. Okay, so we reduce the bias when we have n minus 1, which is decreasing the margin of error here. Okay, so let us try to consider the given example that we have here in the study. Okay, so the variance using 5 here, let us try to consider this data set. Five, 3, 1, 4, and 3. So 5, 3, 4, and 3. So we're going to get the mean again on this case. So because we are going to consider now the data set. Okay. So here, finding mu, population mean, that is equal to 5 plus 3, then plus 1 plus 4 plus 3. Okay. So, getting the sum of 5 plus 3, it is 8. Plus 1, 9. Plus 4, 13. Plus 3 is equal to 16. No? Okay. 5 plus 3 is 8. 9. 13. 16. Okay. 8, 9, 13, 16. So that is 16. That is the sum. Then we have our n is 1, 2, 3, 4, 5. Divided by 5. Okay, wait. Plus 2. Plus 2. So that is, our data now is 5 plus 3 plus 1 plus 4 plus 3 plus 2. That will make 18. Divided by 6. So we're making it 6, so that we'll not have, will not use a calculator anymore, or will not have the difficulty of showing the illustrative example. So 18 divided by 6 is 3. So our mean, population mean is 3. Now take note that in the measures of variation, we have the formula. The formula is omega squared, that is summation of x sub I minus mu squared all over n. No? All over n. So let us have to make a column again of our x sub I, so which consists of 5, 3, 1, 4, 3, and 2. Then we are going to subtract this one by the mu, which is 3. No? So minus 3, minus 3, minus 3, minus 3, minus 3, minus 3. So this is our mu. That is 5 minus 3 is 2. 3 minus 3 is 0. 1 minus 3 is negative 2. And this is 4 minus 3 is 1, 3 minus 3 is 0, and 2 minus 3 is negative 1. Since this formula asks us to square the difference, so we square this one. This is going to be squared, okay? This is x sub I minus mu. Then here we're going to square this one, x sub I minus mu squared. So what is the square of 2? That is 4. That is 0. That is 4. Then this is 1. 1 times 1. That is 0. Negative 1 times negative 1 is 1. So we will get now the sum because it says here the summation. So the sum is 4 plus 4, 8, 9, 10. So our sum is 10. Now applying it here, 10 over our n, which is 6, no? So 6. So 10 divided by 6, we're going to consider that how many 6 are there in 10. So that is more or less, that is 1.67 to roughly estimate it. Now, so 1.67. That is our variance. Now, let us try to go into the sample variance, the S square. What differs here is they only have a difference in terms of n because your n here will be subtracted by 1. We will reduce the given n by 1. So, if our sum is 10, so we'll have 10 over 5. So, that is going to be 2. So you look at it, it's very close because 1.67 can be rounded off to 2. So that's why this sample variance can be used to generalize the population variance. Okay, so that is on the study of the variation as a measure of variability, variance, no? As a measure of variability. So this is now the result of the variance on population and the sample. You can see that the difference between the two, that 1.67 can be rounded off to 2. So you will understand this better when we'll proceed to the study of our measure of standard deviation. So the measure of standard deviation, we can use actually here, let us try to look into, okay, the standard deviation is the next measure of variability. So there are, we have mentioned already, the first is the range, the second is the mean absolute deviation, then the variance, then this one, the fourth one is the standard deviation. Okay, the standard deviation. Okay, the standard deviation, you simply obtain, okay, so if the variance, the population variance is square, then that is equal to the summation of x sub I minus mu squared all over n. All you have to do is remove this one, okay? We are going to raise this one to the power of 1/2, raise this one to the power of 1/2. By the way, it's here 1/2. So what will happen now is this is going to be 1. So your population standard deviation is simply the square root of, because this is raised to the power of 1/2, it will become your radical. The index of the radical is 2. Then the summation of x sub I minus mu squared all over n. So in other words, we'll just simply get the square root of 1.67 as solved in our variance. So likewise, in our standard deviation, so that is s is equal to the square root of 2. No? So get the square root of 2. That is our result in finding the value of our standard deviation. So that's all for this afternoon. So we have ended up our lesson in the study of variance. By the way, if you will you get this one, what is the square root of 1.67 and the square root of 2. So if you're going to consider that value here, then you will appreciate that the homogeneity of, because the standard deviation speaks about homogeneity of the data. So if your S is less than 3, that is homogeneous. You have a homogeneous data. If S is greater than or equal to 3, your, let us erase this first, okay, it's very dirty na, no? So, is less than or greater than or equal to 3, then it is hetero